Today we prove the big product rule. Determinant of AB equals determinant of A times determinant of B. Then we use it to prove the invertibility test. A is invertible if and only if determinant of A is not 0. Intuitively, B scales volume by determinant of B. Then A scales the new volume by determinant of A. So the composition AB should scale volume by the product. Nice intuition. Now we must prove it. Because math does not accept vibes as legal tender. Fix A. Define a function f sub A by applying A to every input vector, and then taking determinant. The trick is to show this new function is another alternating multilinear function. We have seen that creature before. It has very few career options. Linearity comes from two facts. A is linear, and determinant is multilinear in its columns. Alternating is also automatic. If two input columns are equal, then after applying A, those two columns are still equal. So the determinant is 0. So f sub A is alternating and multilinear. It is not necessarily normalized, which is exactly where determinant of A sneaks in like a tiny algebraic gremlin. From the previous determinant story, any alternating multilinear function is a constant times determinant. The constant is its value on the standard basis. For f sub A, that constant is f sub A of the standard basis, which is determinant of A. Therefore applying A to all columns multiplies determinant by determinant of A. That is the whole engine of the proof. Now let the inputs be the columns of B. Then applying A to all of them gives the columns of AB. So determinant of AB equals determinant of A times determinant of B. Proof complete. No six-term expansion. We have evolved past cave mathematics. Barely. If A is invertible, then A times A inverse is the identity matrix. Taking determinant and using multiplicativity gives determinant of A times determinant of A. Inverse equals determinant of identity, which is 1. A number that multiplies something to give 1 cannot be 0. Even algebra agrees that 0 has no comeback arc here. Conversely, suppose determinant of A is not 0. If A were not invertible, its columns would be linearly dependent. But dependent columns force determinant 0, which contradicts determinant of A not being 0. So A must be invertible. The determinant detects whether the columns still span real n-dimensional volume, instead of collapsing into linear algebra soup. The product rule comes from uniqueness of the signed volume function, not from expanding a terrifying sum and praying to notation. Next, multiplicativity will make row operation rules systematic. Computation is coming back, unfortunately, but this time it has paperwork.